Hi, this is Sir Aris. Now let's talk about formal definitions and notations. Formally, infinite series in general can be written as sum of a1 plus a2 plus a3 and so on up to an, and it extends uh, up to infinity. So for example, you have a series with general nth terms as you have 1 squared plus 2 squared plus 3 squared. So the nth term can be written as n squared. We can also have x minus x squared plus x cubed over 2 and so on up to minus 1 to the power of n minus 1 times xn divided by n minus 1 factorial. In shorter forms, we can write them as 1 squared plus 2 squared plus 3 squared uh, and so on equal to summation. So we use a sum symbol from n equals 1 to infinity of n squared. On the second one, you have x minus x squared plus x cubed over 2 and so on. And we can write it as, again, a summation of from n equals 1 to infinity of this term. Sequence is a set of quantities. So the an terms in a series are formed as sequence. Another example is the sequence Sn of partial sums. Our task is to find the limit of a sequence as n approaches infinity. For example, find the limit as n approaches infinity of the sequence with terms of this form 2n minus 1 to the power of 4 plus square root of 1 plus 9n to the power of 8 divided by 1 minus n cubed minus 7n to the power of 4. So to take the limit as n approaches infinity, we can simply rewrite this expression so that when we substitute infinity, we will be able to cancel terms until we are left with number. So one way is to divide the numerator and the denominator by n to the power of 4. So here we put n to the power of 4, n to the power of 4. Each term in the denominator divide them by 4. So n4, n4, and n4. Okay, so here in the numerator, we place n to the power of 4 inside the parentheses. So you get 2n divided by n, so that's 2, minus 1 divided by n. We place n4 inside the square root, that becomes n to the power of 8. So we have 1 over n to the power of 8 plus 9 times n to the power of 8 divided by n to the power of 8. Divided by 1 over n4 minus this becomes 1 over n minus 7. So here, if we substitute n by infinity, we'll get terms divided by n as 0. So you are left with 2 to the power of 4 plus square root of 9 divided by minus 7. So 2 to the power of 4, that's 16 plus 3 divided by negative 7. So that's minus 19 divided by 7. Another example, let's consider the limit as n approaches infinity of ln n divided by n. We can use L'Hopital's rule since the limit, if we substitute n, we get an indeterminate form. So we take the derivative of ln n, we get 1 over n, and the denominator n, take the derivative, that's 1. Substitute n by infinity, you get 0. Here, we assume that the derivative with respect to n is the same as if this n is a continuous variable. Now, another example. Find the limit as n approaches infinity of 1 over n to the power of 1 over n. This is a little bit difficult, but there's a trick. We can take the exponential of the ln of this term. So that doesn't really do anything on the term. It's just the same. because we're just taking exponential of ln of a term is just equal to the term. But the advantage is that we can write ln 1 over n to the power of 1 over n as 1 over n times ln, like here. Okay, so ln of 1 over n can also be written as negative ln. So we have 1 over n, ln over n, or we write it in this way. And we can recall the previous example where we found that ln n over n, taking the limit as n approaches infinity, that's 0. So if we substitute n here, we can get 0. So our final answer is e to the power of 0 or 1.